Hello, everyone. Welcome back to the Astro Imaging channel. We're going to have Tim hosting tonight, but Tim's kind of under the weather, so I'm pinch hitting. Tonight we have Sean Walker is going to talk to us about a very interesting sky survey. We've all done little pictures of HA, probably all of us have, about a little postage stamps view of the sky on some interesting target. Well, Sean and his group have done a complete sky survey. I don't know if it's complete, but they've done a few thousand. He's going to talk to us about that. But before we get on to Sean, I'm just going to share my screen for a moment, tell you about some of the upcoming shows. Let's click this button. Share entire screen. Here we go. Everyone see that? So tonight we have Sean about the MDW Sky Survey. I'm very interested. We all start out with Hydrogen-Alpha. This has got to be a tremendous project. Next week, we have Tom's going to talk about a NINA plugin. And a lot of NINA users, as we found out tonight. He has a
I'm not seeing your
scheduler.
screen, Eric. Has anybody else not seen it? I'm not seeing it on YouTube either.
Oh, I'm sorry. Am I not sharing my screen?
Okay, there it goes. I think
Oh, that was
a weird glitch. It was just a weird glitch. I think you're good.
Okay. Well,
Cool.
Let me start over. So tonight we got Sean Walker going to talk us about the MDW Hydrogen-Alpha Sky Survey. Next week, Tom Parker is going to talk us about a NINA plugin to do scheduling, and we all love scheduling. And we're going to give him a minute or so, once I finish gabbing here, to give us kind of a preview of that. And after that, Tim, our own Tim, is going to talk about equipment for processing. He's got lots of interesting things that he's put into his system. He's going to talk to us about that. After that, Steve Ziegler. This is a presentation I'm really interested in. The solar eclipse coming up next week, figuring out how to do it, what are best practices. And after that, well, you can read the schedule. We have Alistair on the wide field mosaic. And after that, Linda Thomas Power. And you can all go to our astroimagingchannel.org, read the schedule, and see these things for yourself. Now, if I can stop presenting. Hopefully everyone saw that. So, Tom, why don't you kind of give us your elevator pitch on your presentation next week?
Sure. So I think the majority of folks here are familiar with NINA. Obviously, there was a Sky and Telescope article, I think this month, that provided a little more introduction. And if you've used NINA, you know about the advanced sequencer and the capabilities that it has. Provides a lot of very sophisticated equipment control, automation, sequence scripting. But when you're trying to prepare your sequences each night, it can get kind of cumbersome, especially if you want to image multiple targets in a night or set up multiple targets over a sequence of time. So the Target Scheduler is a plugin that can help automate this process. Basically, you manage a database of your projects through the plugin interface. And then at any given time, during the execution of your sequence, it can pick the best target image based on various criteria that you establish. Obviously, the visibility, a priority, minimum time, a meridian window, and a rules engine can also weigh competing criteria, help pick targets.
Don't tell us everything now. I mean, we got to save something for next week.
Okay, am I going over my
I think the hook is going to come out here in a moment. But yeah, that's a great introduction. I'm sure everyone that's a NINA user is going to be interested. I'm interested because I have friends who use NINA, and everyone should tune in next week to hear from Tom.
Great.
And if we're all set, I want to say Mr. Unknown is going to present, but we really know that's only a name on the screen. And this is really Sean Walker going to tell us about his H-Alpha Sky Survey project. So the screen is yours, sir.
Thanks a lot, Eric. Anyway, let me get this running here. you all seeing this?
Yeah.
Okay. Anyway, I'm here to talk a bit about our a little more than a little project, actually. This is the MDW Sky Survey, which was put together by me and a couple of other friends, which we'll get into in a moment. It's named after David Mittelman, Dennis Cicco, and myself, Sean Walker. Anyway, the project's goal is to map the entire sky in hydrogen alpha light at moderately high resolution of 3.17 arc second per pixel, okay, with a 4-hour cumulative exposure across the entire sky. And this grew out of several interests from each of us. Anyway, Dennis and myself worked together at Sky and Telescope since the early 2000s, and but the two of us, well, Dennis was a pioneer in digital imaging and H alpha imaging with film before that point. Anyway, he and I got really into shooting wide field images with digital detectors as they were getting bigger. Anyway, our first project that we executed was a mosaic of 15 frames spanning about 4,000 square degrees of the sky. That's roughly 10% of the entire sky. And we published an article on the piece in S&T in April of 2009. Anyway, this was our final version of that. And that's roughly, I think, 4 hours per panel. At we used, I believe, what did I say, a 50 millimeter lens, a Hasselblad lens that we used for this particular project, and this gives you a pretty good idea of how much it covers on the sky. This wasn't a terribly high resolution project, but it was. It gave us a real nice taste of what's possible with camera lenses and the wide field, the big chips that we had at the time. So we, a year later, we set about on a second version of it, and we stepped up to a larger camera and a larger lens. Dennis really likes to put together systems. He's a machinist by his other trade. Anyway, he put together a system where we attached a Hasselblad 110 millimeter lens, f2 lens, onto a Apogee U1600 CCD camera, U16M, sorry. Anyway, after each night, this is what his stuff looked like, with all the frost in our lovely New England skies. But it actually went a lot better than the first project, and we managed to sweep this all up within about 3 months. This was, it ended up being about 25 panels, okay? And this was at still a coarse resolution of about maybe 12 arc seconds per pixel. But it shows you how deep you can really get from just pretty light polluted backyard. Dennis shot this, by the way, from his backyard in Sudbury, Massachusetts, which is only about 20 miles from Boston. It's right between two major cities in Massachusetts, Worcester and Boston. Anyway, so it's not particularly dark, but as we all know about imaging with H alpha filters, it blocks a lot of, not all of, but a lot of the light pollution. So you can really pull out some of this faint stuff in the sky. Anyway, here's the image. That's actually scaled properly. Dennis took a wide angle shot that I what do you call it, registered and put our mosaic onto the sky there. That's actually his house too, in his backyard. But after a little while, Dennis and myself and our friend David Mittelman, who Dennis had introduced to me in the late 2000s, we were kicking around the idea of how to continue our H alpha work. What more could we do? I thought we should continue on shooting more of the sky so that we get all the way through the summer and whatnot. But we wanted a lot more resolution, because camera lenses are great, but you start to see the limitations, as you'll see in a few. I'll show you a comparison. The limitations of a small aperture okay, versus a large one in mosaicing. First experiments were with a 200 millimeter Officina Stellare Riccardi Honder's astrograph. And that summer we did a 30 panel mosaic of Cygnus. And this is how it came together. Looks pretty nice, and it very decent resolution. However, there is a few issues with the optical system that I'll get into in a moment. But it still resolved a lot more detail on the nebulosity compared to with the camera lenses. Now, the big part of that is because, you know, with the larger aperture, your stars get smaller, and because you're resolving smaller details. So the stars start to get out of the way of our real target, which is the nebulosity or in the sky. Okay, so the results were promising, but there was a lot of limiting factors. First off, obviously, our New England skies. As I said, H alpha will block a lot of light pollution, but not all of it. Let's see, we had a 16803 detector, and that was a little too large for the specifications of the RH200. The corner stars looked pretty bad, and there was no way to correct for it because it wasn't designed for such a large chip. Also, reflective optics require minor recollimation with changing temperatures. And as they're moving across the sky, they can fall out of collimation. The last problem I had with it too is that at certain angles, we ended up with some internal reflections from bright stars, which were problematic. So while we're grouping to discuss the results, David suggested that we shouldn't limit ourselves to only a certain region of the sky. We could perform a systematic survey of the entire sky shot remotely from a dark sky location using off-the-shelf technology, which was kind of a big deal 10 years ago. All right. At the time, current all-sky H alpha surveys were very low resolution. This one is probably the most famous, and you can access it online pretty easily. This is the Virginia Tech Spectral Line Survey. And this was mostly done at radio wavelengths, I believe. Let's see. David was already a member of New Mexico Skies and had founded several observatories for colleges and for private use. He really likes to put his mind to something and really get into it. Here's a couple of his setups. At the left, you see the our survey scopes. In the middle is one of the observatories he put together for Middlebury College, and another one at the right there. But oh, let's see. He also had a plane wave CD, a 20-inch plane wave, and a TAIC FSQ 106. But his biggest project at the time was resurrecting a 36-inch Bowler and Chivens Newtonian that he bought from, I think, Yale or some place in Connecticut. Anyway, and he shipped it out to New Mexico to rebuild it. Anyway, in Dover, he had a plane wave 17.5-inch CDK on top of his house with an observatory there, and several other scopes. There's David here at groundbreaking of one of the observatories in New Mexico. This is the Bowler and Chivens project, which he was working on at the same time. Anyway, give you an idea of what they were playing with. But our sky survey commenced planning in the fall of 2015 after those initial tests. Okay, we settled on two AP 130 Starfire apochromatic refractors as the primary instruments. In addition to that, they were paired with FLI PL16803 CCD cameras, which were kind of the cream of the crop back in 2015. And of course, we matched them with 3 nanometer H alpha filters from Astrodon. Our resolution is about 3.17 arc seconds per pixel. I forgot to mention in this that we customized the telescopes so that they weren't using the field flatteners the way that they Roland had initially intended it, because the telescopes and flatteners weren't initially spec'd for that large of a chip once again. But we worked with Roland to adjust the spacing to cover the entire chip, produce round stars, and it worked out. And we ended up changing the focal ratio so that we were imaging at f4.5 in our setup. Anyway, so Dennis went to work building all these imaging rigs. We replaced the focusers with FLI Atlas focusers in order to eliminate issues with dusts and flexure. Now, this is a closed system. We're not using filter wheels. The filters are mounted in place, and therefore we generally don't have changing dust on the at least on the internal surfaces of the CCD and the filter. So, as I just mentioned, it's sealed. This is building some of the parts here, customized parts. As you see on the far left, that's where the filters are installed. I think they were 65 millimeter square filters, and then each of these parts are to accommodate the different sections of the telescope there. There's the filter in place, mounted right to the front of the camera. And here's one of the first rigs when we were testing them out. We're using an auto guider system, although it's probably not necessary. We still find it useful, particularly at the time it was hard to pre-program dithering without auto guiding. Now you can do it, I guess, in Nina without auto guiding, really easy. But, you know, again, we worked with what was available at the time. This is the matching pair when the getting ready for their shipment down to New Mexico. So once planning and executing an all-sky unintended, planning and executing an all-sky survey required some custom software, all right? Our first test, we first tried using software BISC's the Sky X that has a mosaicing feature, but unfortunately it's designed for doing pretty high resolution small mosaics of like a galaxy or two rather than the whole sky, and it didn't take into account the three-dimensionality of the warping of the sky as you're changing the directions. So we had to approach them to rework their mosaicing feature. Steve Bisque went to work for us on it and redid the whole thing so that once you got it to work and plot along the entire sky, this is how we were planning out our plan of attack here. This actually isn't the final version of our map of the sky, but it's pretty close to what it looked like before we got going. Anyway, but after months of testing, the survey began operations in mid-June 2016. As you saw earlier, these are the two scopes on generally during the day. We're using flip flats to create our flat fields because it's a lot easier than working with sky flats. Or of course it was at the time. We were on matching software BISC mounts. I believe these are the ME Plus. They work really great. The reason we're using two scopes now is that we were our intention is to get 4 hours of exposure total for each field, okay? But the way the software is written, we were controlling these using, I'll get back to that in a second. We're controlling these using ACP. And the way the software is written, it's targets the field as it's approaching the meridian, basically when it's highest and best placed in the night. But it'll only target each field, you know, when, you know, it's not cloudy. So sometimes you could take many months or even years before you complete a field. We were just working with targets of opportunity rather than just targeting one field at a time and moving to the next. So we split this up amongst the two telescopes. AP1, as we called them, the scope on the right in this image, would shoot fields, 6 20-minute exposures, or 2 groups of 1 hour, okay? And AP2 on the left would shoot fields 7 through 12. These would all be dithered and then finally combined together into the final 4 hour reduced image. As of right now, well, we've nearly completed the northern hemisphere down to -32. There's only about 12 hours of data left to capture, okay? The entire sky is going to require 4,000, a little over 4,000 fields, each consisting of, you know, as I mentioned, 12 times 20-minute exposures, okay? We could shoot to -32 from New Mexico skies, and that consisted of 3,178 fields. We have recorded data on 3,172 fields, completed all of those, 4 hours of those fields. And we just have a couple of reshoots and finishing up the last fields. We've actually recorded data on every field in that. And we've already started moving telescopes. Unfortunately, going back a little bit, not long after commencing the operation, David was stricken with an aggressive form of cancer. To help lift David's spirits while undergoing treatment, we went public with our project rather early in the process, to allow David to enjoy some of the fruits of his labors. This was an early map of some of the data as I was accumulating it by March of 2017. A very incomplete map, but you know, give you a pretty good idea. This is the from the summer to the winter sky here. If you look, you can see Cygnus on the right there, and on the left-hand side is Auriga, and towards Gemini and whatnot. One of the first releases we had of this was picking up all this hydrogen nebula, hydrogen alpha nebulosity around objects that you don't normally associate with wide field hydrogen nebulosity, like M31. Unfortunately, shortly after that image, David passed away. But the Mittelman observatories and MDW Sky Survey are continuing operations with the support of the Mittelman Family Foundation and the goal of seeing David's projects through to completion. Asteroid 16779 Mittelman is named in David's honor by Dennis himself. He proposed the name. He had discovered the asteroid and named it after David. Anyway, the time span for was estimated to be about 5 years to complete the project. That was pretty optimistic, it turns out. It's looking more like 10 years. We've just completed 7 years and accumulated 4.5 terabytes of data, and also completed nearly 80% of the entire project. From New Mexico skies, you can see 80% of the sky. It's that last 20%, which, you know, is really gorgeous that we can't see up here. As I mentioned earlier, okay, 3,174 fields of 4,100 have been completed as of a week and a half ago, before the moon really got in the way. As I mentioned, due to the nature of the script in ACP, the survey targets are best placed each night for 1 hour blocks. So many of the fields were 25, 50, and 75% complete. I would stack these things together just to see what we would get. And yeah, as I mentioned, 99.5% complete as of a few weeks ago. This is what this looks like when I open up my stacked fields every day. When want to put together some of this stuff. Anyway, here's a couple of our results here to give you an idea. I'm not sure if you guys are familiar with this object in Lacerda, but it takes up a good quarter of the constellation. I believe this is SH2-126, a large hydrogen nebulosity field, obviously. Yeah, oh, here you go. Here's the entire constellation where I've inserted the lines and whatnot. To give you an idea of the increase in resolution, this is Simis 147 in Taurus. This was shot on our earlier survey project with the 110 millimeter lens. This is the same field with the AP 130s, okay? Far better resolution. If I blink back and forth, let's see if I can get back to that. You can really, as I said, the stars really start to get out of the way and reveal even fainter and finer detail in the nebulosity in the background. Okay, here's the Seagull Nebula with that 110 millimeter lens. This is it with the on our survey data. By the way, notice all the smaller planetary nebula. If you look at to the right of middle, there's a large round planetary nebula right in the Seagull that I wasn't aware of before this. It was known for a few years. I'm not claiming to discover it. Anyway, this is a really interesting field here, showing you again the really interesting faint filaments of nebulosity that you can see in the night sky. I'm not sure if anybody recognizes this field, but that's Vega is the brightest star there. This is all of Lyra. You can see it pretty carefully going down towards the lower right there. You can actually make out the Ring Nebula between the two stars there. But what was really interesting to me is those large arcs of nebulosity. Those actually go all the way back into Cygnus. Here it is again, where you can see it going into Cygnus a little better. It gives you a really a good idea of how when you're zooming out with these large mosaics, how you can actually see more of these large scale features. And here's all of Cygnus with Lyra at the north above it. To the right in this image, that large cloud of nebulosity actually surrounds M71, the open cluster / thought to be a loose globular cluster. Once again, here's Lyra showing you with the constellation lines. I intend to, in the future, put out a book with of constellations in H alpha. That's one of my pet projects with this project. Here's another view of the entire constellation of one that was that Vulpecula, or I'm sorry, Sagitta. Oh, here's that area with M71 that I was mentioning earlier. The bright object, as you can see to the top right, is the Dumbbell Nebula. Really gives you an idea of the stuff around it. And that's part of what I find fascinating in this project, is putting, being able to understand where things are located in the sky. I've become very familiar with where objects are based on their right ascension and declination, and then their proximity to other objects. This is Cedarblad 214. Here's a much wider field with that same area, but also including much of Cassiopeia and into Perseus. I'm sure you recognize a lot of the objects in here, including the Pac-Man Nebula at the lower center, and the Heart and Souls on the left there. If you look carefully, you can see below the Heart and Soul, you can see the double cluster, and that also is surrounded by faint nebula, hydrogen nebulosity. It's burning off the nebulosity that it's thought to have been born from. Here's a shot of showing the entire constellation of Cassiopeia from our survey. As I mentioned earlier, here's the double cluster surrounded by that hydrogen nebulosity. The cloud is the color data comes from the FSQ that we also use for follow-up observations. The FSQ is populated with a full retinue of RGB and narrowband filters from Astrodon. Occasionally, we've come back to, and in fact, I've done some follow-up work for other scientists too, and we'll get to that in a moment. Here's the Veil Nebula that really starts to look pretty interesting when you're at this image scale, where it looks like a kind of a big screaming skull. Here it is without the stars. Once you get the stars out of the way, you can really see some interesting filamentary structure in the vicinity there. That's just virtually impossible. Now, you see hints of it with the stars there, but when you take it out, it really leaps out at you. Here's an object that was pretty interesting. Sivian 2 was discovered in 1972 on photographic film, and then nobody paid any attention to it again until I stumbled across it once more doing this survey. By the way, Sivian 2 is not far from M31. You'll see that in probably a moment or two. Here's a color version. This color data was courtesy of Rogelio Bernal Andreo. Once again, wider field of view showing more interesting proximity nebulosity. The area on the left here is mostly in Camelopardalis, and there's a nice bow shock at the top left there. That's around, I can't think of the name of the star at the moment, but I might be Alpha or Beta Camelopardalis. Again, without the stars, it really starts to reveal a lot more of the filamentary faint nebulosity in the sky. Here's another familiar object in the winter. What's it? IC 443 and 444, and there's the monkey-headed nebula, NGC 2174, I believe, on the right, lower right. And as you zoom further out, those nebulosity are in the central in a larger bubble here. I believe this is called the Gemini ring, or the Auriga Gemini ring. And you see when I remove the stars and enhance the image, you can start to see the large circular region that it surrounds. In fact, some of it is real filamentary, pushed out by the supernova that I believe was from the result of which produced IC 443. Here's another large circular region of nebulosity that you get to put into context. Right in the middle is the Eagle Nebula, is at M16, and below it is the Omega M17. But if you look to the right, to the left, you can see a lot of bow shocks emanating from that central region there. These are pretty common along the galactic plane. Here's a familiar object that starts to look unfamiliar when you go deep in H alpha. This is the California Nebula. Was that NGC 1499, and it starts to look more like a scimitar to me at this depth. Another famous area in the heart of Cygnus here, including NGC 6888. And as you zoom out, you get a bigger picture. This shows you all of the constellation of Cygnus. This gives you an idea of the image scale also in the survey. This is 100% crop of the M1, the supernova remnant in Taurus. So you can go from that really large, wide field of view down to fairly high resolution. I mean, some would find that 3.17 arc seconds not terribly high resolution, but in the scheme of things, particularly in a wide field survey, it's pretty uncommon. Again, this is here's M83. As I mentioned, I think I mentioned earlier, the image scale of the survey lends itself to revealing large structures not visible with lower resolution images. And when you post these kinds of images online, professional astronomers tend to take notice. While I was assembling some of these mosaic fields, particularly the ones in northern Cepheus, I noticed bow shocks that continued through several of these fields. And then I started to stitch them together. Now, I'm less interested in making a really gorgeous image and more interested in finding out finding this real faint stuff. And sometimes that's buried right along the edge of the noise in your image. But this was pretty interesting. It turns out this object was a suspected supernova remnant G107.0 plus 9.0. It was first noted in ROSAT X-ray data. Our image was the first to detect the object at optical wavelengths, and our data led to the identification of the brighter areas where spectra could be obtained with large observatory class instruments, and allowing our survey to be part of the discovery and verification process of these objects. It was the first of several discoveries by Robert Fesson at Dartmouth College, and who brought us in to help identify some of these objects. Here's the paper that was published on this one. Yeah. And here's another one, G70.0. They have real sexy names, don't they? Anyway, again, we got credit for helping to actually confirm that these objects were indeed supernova remnants and no longer suspected. Here's another interesting object that we came across in our data. I was asked if in the field near M82, M81 and M82, if I saw this line going through the image. It's not particularly close there. If you look in this mosaic at the far left there, at the black spot at the top left of that field, this is a negative image, but that's M82. That what you're looking at is a really extremely faint arc of it's a bow shock passing nearby through the solar system that spans a very large section of the northern sky. Ours was a 30-degree long arc, first discovered in ultraviolet wavelengths, and ours confirmed it in visual wavelengths. It's called the Ursa Major arc now, and some magazine wrote about it too. Anyway, here's another bow shock that I've stumbled across in this one, I believe, is in Hydra or Pyxis, one of the two. Been a little while, but you start to see a lot of other objects like this too. There's a newly discovered supernova remnant in Monoceros. I'm not sure if you can see it, but it's in the lower right of this field. This is a close-up of that area, but it's really hard to see it with the stars there. When you take away the stars, you can it actually reveals a lot of that the expanding shell from the object. So I followed this up with some O3 and color data and sent it off, posted it online, and within 2 days, the discoverers of this nebulosity contacted me, asking, how did I find this object? And it wasn't terribly hard. Just look at papers and look at my images. Anyway, in October of 2 years ago, I returned to that Orion Eridanus bubble that I shot we shot with our first project with the wide angle lenses there. Here's the first one with that 50 millimeter lens that we were talking about. Putting it together in the survey is a manual process. You can't really just throw this through software and it'll automatically stitch it together. I'm using PT GUI to manually align at least 10 stars along every edge of these frames. I think this was ended up being about a 400 frame mosaic in this particular area. But here is the same region, you know, with our survey data. And it shows a lot of filamentary structure coming further south than actually the initial discoverers of this nebula, Eridanus Orion bubble, were aware of. And we're actually in the process of writing a new paper on this. A lot of these the shock waves, this is along the southern part. I believe that's Rigel you see at the top right there. Taking away the stars again, I'm just fascinated by the gossamer threads of nebulosity permeating the region here. As you zoom in closer, you can see like these towering structures and whatnot still left behind here. Anyway, in the summer of 2022, we partnered with Columbia University to use the data for studies on stellar evolution by astrophysicist Mary Putnam and the entire astronomy department at Columbia University. They're currently refining the astrometric precision of the data and calibrating it to known sources. Here's a screen they gave me of some of the updates on measuring the astrometry in our data there. They're also doing photometry out of this, which I find quite surprising since, as I mentioned, sometimes our baseline between 1 hour of data and the last hour of the data can vary anywhere between weeks and years. In fact, I had one field that was just started at the beginning of the survey and we just finished it a few months ago. Unfortunately, I didn't, it was 7 years between the images, but I didn't see any moving stars. I checked though. But they're also measuring the extinction based on the galactic latitude and above the horizon too. Yeah, apparently, you know, our data was well within what they were expecting. And of course, they're also mapping the faint filaments of nebulosity extending far away from the galactic plane. This is one of the undergraduate, Daniela Furman, is mapping a lot of the nebulosity around we call it the Horsehead here. Columbia is also calibrating the data in preparation for our first public data release, scheduled currently for January of 2024, where our reduced FITS files should be available for anyone to download. Okay. This spring, we closed AP1 and shipped it down to Obstec in Chile at their El Sos Observatory. And it's going to be followed later by AP2 once we finish up the reshoot fields, and we should be done within a couple of weeks. Actually, by the winter of this winter, we should have the scope on its way to Chile to continue for the rest of the fields there. Here's AP1 in its new home and some of our first fields that came down only just a few weeks ago. Let me see. We also switched up when we moved to the Southern Hemisphere. Working with equatorial mounts, a German equatorial mount was good in certain ways, but we switched to a plane wave, a single arm fork, so that our telescope, first off, we never have to do a pier flip ever again. And all of our data will now all come down with the same orientation. I won't have to figure out which way is north in every field. On the AP1 and AP2, when they were shooting from in New Mexico skies, some of the images are shot on one side of the pier and some of them on the other. So yeah, it can be a crapshoot which way was up. But it was only rotated 180 degrees. It was never 90 or whatnot. Anyway, so looking forward to see what we're going to be picking up in the southern hemisphere. And that's what I got for you guys. Any questions?
This is fascinating. I think we're all just staring at your images, wondering, how what we're doing kind of fits into it. That's just incredible. I have a quick question. When you put it on the L mount, that's a long telescope.
Yep.
You must have come pretty close to the base.
Well, it's not that long, and it clears the base pretty well. The L350 is pretty large compared to just a 5-inch scope. We actually have a third scope in the works that's going to be going down there too. So before that happens, though, we might be having both scopes on one mount, because it can take it on both sides of that. But yeah, it clears the base on it. It was a little iffy. I think we might have had to put some weight on the front end to push things forward.
Can you tell us a little bit about how you process the images so that they're somewhat similar and they all come out together?
It's fairly basic. I mean, we're calibrating everything with good flats and darks and flat darks. And let's see. We take fresh darks every night. I mean, not darks, fresh flats every night, but I take new darks every 2 months because they don't degrade very fast. But I evaluate all the data as it's coming down every night. So I have to, we could rely on software, but it can't tell you if it was partly cloudy or kind of hazy. So I monitor the background levels of everything. I reject data that has, say, above like 200 counts for a background. Our general data set is looking like our background is average about 20 counts to 20 to 40. I will let it go if it's up to maybe in the 100s, but after that you start seeing gradients that'll affect you, particularly on when you're really stretching the data like I try to do.
Well, how do you do your mosaicing? What software do you use?
Well, I use a variety of different software. If I'm just chucking a bunch of several dozen fields together to quickly see if what's in the area there, I have a free program that I was using that Microsoft used to make called Microsoft Ice, and which they inexplicably stopped supporting a couple of years ago, but I still use it. It works really good up to about 150 fields, and then it really starts to fall apart. And it also eats RAM. But in more complex fields or ones that it didn't automatically register. Also, ICE doesn't do a fantastic job of balancing the background on each of your images. It also isn't well calibrated. It only accepts TIFF files or JPEGs. So, that's not a scientific program to work with. I'm also doing mosaicing in PixInsight. I was using AstroPixel processor, which has a pretty good mosaicing software feature where it will stitch together FITS files that will come out as FITS files. That's a big benefit. Or if I'm just assembling a bunch of TIFF files that I'm trying to make a nice, large, pretty picture, I'll assemble those manually using PT GUI.
Molly, I saw there's a question online.
Yeah, so you answered the first part of this of Nebula Photos question about software. Oh, where did it go? They wanted to know if you think that your images might end up in Aladdin at some point. Are you familiar with
Yes,
Aladdin?
I'm familiar with Aladdin, possibly. I mean, we've partnered with Columbia, and right now they get first dibs on that, but it might be eventually available through that or even through the Worldwide Telescope.
Oh yeah.
You ever thought about posting them on Wachowski Archive?
I thought about a lot of things. I just have they have limited time. In the past several months have been just keeping up with the data. Working on this large time scale, at first you slowly accumulate data, but when you start filling up those wells, they start coming quick. And at the end of a year or two ago, it started turning into, we would be completing like a dozen fields in a night or two, so it was a lot of work just keeping up with the data rather than assembling them into images to ship off everywhere else.
I was going to say, do you have a life outside of this project?
Well, yes, I do planetary imaging in my backyard here from my own observatory, and I do other imaging, and I have a lot of other interests. So yeah, this does eat up a lot of my time, but it's even after 7 years, it's every morning it's exciting to turn on the computer. It downloads the last or the data that it's still shooting when I get up in the morning, and seeing what I have to work with. It's particularly exciting now because I'm not terribly familiar with the Southern Hemisphere. I've only been there twice, once of them a month ago.
Well, I imagine it's like doing this giant, 1,000-piece puzzle, and you're getting down and you got a few pieces left, and you're just so excited about sticking that last piece in.
Oh, exactly. And in fact, I got started stacking small amounts of the data initially, so David could be able to see some of this stuff, and only having an hour or two to work with, I'd end up having to restack these fields several times. And sometimes it can get a little tedious, but it led to some of these earlier discoveries, like,
Hey,
those.
I think something might have happened to the stream. Hold on. Patrick, are you seeing anything weird?
No, it looks okay.
Huh.
It looks okay on mine, Molly.
Weird. I'm on two different browsers and it looks like it ended.
I don't know what the delay is.
I believe, well, it looks to me like it's still broadcast.
Okay.
Yeah, I can see you
Okay.
now, so I
Maybe my
don't think it
computer's
has.
being weird. So go on.
I'm sorry.
Okay. That's all right. I think I was done.
Everything is live here, so if something comes up, we just deal with it in real time.
Oh, understandable. But again, even after 8 years, it's still exciting every day to open up and see what's coming. It was such a relief to start getting data from just south of -32, which sounds very far south, but that's not all of Scorpius.
So if this is all done, I mean, you could fill the side of a building with a high resolution image.
Oh, easily. Yep.
Easily. I mean, do you have any plans where this is going to be displayed in some?
Well, I mean, I would like this to be an online or incorporated into an app where you can zoom into it. That's a little beyond my capabilities, but I'm sure somebody's going to pick it up. In fact, we had been in talks with a few of the planetarium software once we're completed, that they'd be interested in incorporating it into their programs. I think that's where it'd be extremely useful. But also, making all the FITS files available to everybody will make you can be able to do whatever you want with it.
When you say make the FITS files available, you mean literally all the different panels are going to be on a database that people can download?
Yeah, that's the idea.
Will they be
Sean?
processed and integrated or just?
Yes, it's the reduced field, you know.
Sean, have you given any consideration to the fact that when you were in New Mexico, shooting down to -32, I don't know how far above the horizon that leaves you, but the quality of the image may have suffered. Have you ever thought about maybe from down south shooting up a little bit so that you can get better quality out of the ones that were far to the south?
Well, first off, our -32 limit isn't down to the horizon. That's just
No.
as low as the wall was, which is about 25 degrees
Oh, that's
above
not too
the
bad.
horizon. No, it's not
Yeah,
terrible.
that's not
But
too bad.
we are planning on reshooting a lot of the fields that are right along that lowest band, because when it's straight up, you're not shooting through all that air mass, and it definitely makes a difference.
HA is very forgiving. You can, for an RGB, maybe you don't want to shoot to 25, but HA, I would have no problem.
The atmosphere doesn't disturb that red light quite as much as it does.
Yeah, as the blue lights.
The shorter wavelength.
Oh yeah.
So,
I know we made a bunch of choices in this project. A lot of people ask us, why didn't we do 03, or are we going to do 03 after we're done with it? I don't think there's enough hours in my life to really redo this again. But it's open for other people to do. And the reason why we chose H alpha 2 is it's far more prevalent, 10 times more prevalent than 03.
Oh, sure, absolutely.
Yeah.
And reveals the detail
Yeah.
of what's happening out there. I mean, I think that we all started off with H alpha. I mean, because we could, no matter where we were, no matter how polluted our light skies were, we could shoot H alpha and get an interesting image. So that strikes a lot of buttons for everybody.
03 would be interesting for either you guys or somebody to do at some point, since 03 is mainly found for more massive stars. So it'd be interesting to see the distribution of those and how far their gases have expanded.
Right. But if to redo this in 03, I would redo the entire project, and the first thing I would replace is the detector, because I mean, we're locked into it because you want a survey to have consistent data through the entire run. You can't do it, well, we switched cameras halfway through and
Yeah.
So now if you start over, you'd probably go with a nice, maybe full frame CCD.
CMOS, actually.
CMOS.
Yeah.
I'm sorry, CMOS. I meant to say
Exactly.
CMOS.
And a lot of them
CMOS.
are a lot more sensitive than this chip was.
And the 130 has a big image circle too. So
yeah, but there's also other considerations too. Having a big image circle, you would also need an optic that can cover that big image circle. The larger the chip, the more problems that you can run into.
There's a question on the YouTube chat from user Nebula Photos again. Do you take images when the moon is out, or what is your moon avoidance angle?
Oh, we do use a moon avoidance angle, and in fact, most of the time we still shoot all the way through full moon, but I find I end up rejecting the majority of that data. And in fact, we had the option of shutting down the scope in Chile this past week. I opted to shut it down for 5 days because it's tiring to have to reload the same data that is going to be polluted.
True. Yeah.
Generally, the trips of scopes down to Chile is one way. Do you plan on bringing these back somehow?
They don't belong to me. They belong to the Mittelman Family Foundation, and they're going to find a home for them afterwards, I'm sure.
Those 130s are exquisite.
Yeah, they're very nice, and now we have 3 of them. Yeah, but I do know how hard they are to get a hold of.
Yes, they are.
I personally own a AP92, a stowaway, and
another fine scope.
Yeah, well, the big joke on mine is it only took me 18 years to get it.
I have a 130. It sits in my basement in the telescope museum.
Uh,
I've told my wife to bury it with me, which might be a crime, but I don't know. I never want to keep that up. How are we doing online? I don't see any more questions.
I haven't seen any more roll in.
okay.
If you got any last minute zingers, get them in quick.
Yes, if you have any more questions, get them out here. Fascinating project.
Yeah.
I spend a lot of time doing this, but you must spend 10 times that amount of time.
Yeah, geez.
This
Well,
must
my
be
day-
your life for a while.
Well, I guess. In general, every morning, I'm an early riser. I get up at about 5 in the morning and I turn on the my system, make coffee, and then I'm in here by 10 past 5 and looking at our data, seeing what we got. It'll generally take me between an hour and an hour and a half to reduce all the data from the night before. And if I've completed fields, it'll take an additional hour to stack them all.
And then you
The,
have to integrate them into you have to put in the pieces of the puzzle.
Mhm.
And you have to tell ACP that that's got to retake them.
If there's ones that it failed on, you're correct. But oftentimes ACP, it'll just say, all right, it finished those exposures, so it thinks it was done. So
That's what I mean. It's got to be told, no, they're not done. I need them yet, right? Yeah.
right, exactly. In fact, I usually write all these down, and then after I'm done in the morning, I send a list off to Dennis, and he'll reload all the stuff for me, or turn off fields if they've been completed.
So do you do all the processing yourself,
Yep.
or does Dennis do any of the?
No, I do all the processing.
Oh my gosh.
It's
Looks
fun.
like any more questions online? I don't see any more
No, I don't see
questions.
any.
So, this is fascinating presentation, Sean.
Yeah. Gorgeous images. It's so cool. I love seeing all that really deep H alpha that can just come out of the background sometimes, and especially in these dedicated images for it. Really gives you a sense of like how littered with star stuff the whole galaxy is, and sometimes there's H alpha we can see around other galaxies, which is really cool.
There's a lot of small objects that you'd be surprised is surrounded by a lot of complex nebulosity. It's just oftentimes we approach it going without thinking of the surrounding field.
Yeah. Did you happen to catch any of those H alpha like tidal stream like things that are coming off of Centaurus A? Have you seen those?
Haven't gotten to Centaurus A
Okay.
yet.
All right.
because
I'll be
we
looking forward to
just
that.
Started the southern hemisphere.
And,
Okay.
and there was an interesting post about some HA around M31.
I saw that.
Yes,
Yeah.
I was involved in that actually.
And so that's real data. That's not an artifact.
Yeah, no. Actually, what you're talking about too is the O3.
The O3. Yeah.
Yeah, I was part of that one too.
Yeah. That was surprising.
Yeah, that was another project that was brought together by Robert Fesson, and he contacted me asking to verify the discoverer's data. And after an hour, I got not an hour, 10 hours of exposure of O3. I was able to pull it out there. It was ugly, but it's there. If you go to our website, mdwskysurvey.org, you can have a look.
Fantastic.
Awesome.
Well, fascinating presentation. Thank you
Yes.
so much for coming online and giving it to us. I think we're kind of at the end of our program. Everyone that's out there, we held our audience pretty good, I see, through
Yeah,
the
we
whole
did.
program. So those of you that are out on YouTube, join us again and see Tom Palmer give us a little more information about Nina and its thousands of users.
Mhm.
We understand. So if that's the end of it, then Patrick, take us out of here. And to everyone out there, good night
All
or good
right.
morning, wherever you happen to be
Good night,
located.
everybody.
See you next
Good night,
Sunday
See you next week.
or Monday morning.
Thanks for
And-
having me.
And you can stay with us. we continue on with our little session, our chat sessions after the stream ends.
Right.
Right.